All right, so we are recording here. This is Mr. G, and I'm going to do some of these projectile motion problems. So here's one. You've got this ball we're going to be tossing across the room. So it's moving up at an angle, and that motion can be described by two different velocity components. It's moving sideways at 5 meters per second. You can see here. And at the same time, it's moving up with an initial upward speed of 10 meters per second. The total speed of this thing is this diagonal arrow that indicates the total speed, which is 11.18 meters per second. That comes from the whole Pythagorean theorem business. But let's concentrate on these two component velocities. So we can run the simulation here and so again, notice the sideways velocity, that 5 meters per second, that's constant throughout the motion. The other velocity component, the vertical velocity, it's initially 10. It initially gets smaller and smaller as it's moving up in the air because it's losing speed. It's accelerating downward. That means it's slowing down by 10 meters per second every second, and that's just the vertical component. Smaller, smaller, smaller. And at the very highest position, it's no longer moving up. Now it's moving down. Now that vertical speed is increasing by 10 meters per second every second. Boink. Okay. Let me change the resolution on this thing. It'll run smoother. There we go. Boink. Okay. So for this problem, we want to know, let me take a little picture here. Well, let's do this actually. Let's go ahead and trace its motion. All right. So, boink. Okay. Now let's take a snapshot of this thing. And we'll do just a little bit of math. All right, so here we want to know what is the total time it's in the air. And so let's see, so we recall it started off with a velocity here of 10 meters per second. And it's moving sideways at 5 meters per second. We're going to label those two velocities Vy, that's vertical velocity in the y direction is 10 meters per second initially. And in the x direction, it's 5 meters per second. And the velocity that determines how long it's in the air is going to be this vertical component right here. All right. So it's moving initially up at 10 meters per second, but it's slowing down at a rate of 10 meters per second. So it's losing vertical speed at a rate of 10 meters per second every second it's in the air. So then how much time does it take until it stops moving up? Right? In other words, what is this time right here just to get to the highest position? Well, if it starts off with 10 meters per second and it's losing 10 meters per second every second, it's going to take 1 second to stop, right? Or another way of looking at that is just to consider something that has been tossed straight up in the air at 10 meters per second. You can forget about the horizontal motion. Let's just toss something straight up in the air. Right? So V naught is 10 meters per second. And this goes up, and it stops. And we've done this problem before, many, many, many times. So then that means that V final at the highest point is how much? It's 0. It stops at the highest position. And the other information we have is that it's slowing down at a rate of 10 meters per second every second. That's acceleration, folks. And it's negative. That acceleration, the negative sign indicates that the acceleration actually points down. It's a difficult concept to try to visualize that because it's not moving down, it's slowing down. So then technically to make this work out here, A is minus 10 meters per second squared, or meters per second. And yeah, there's an equation that relates all of this, and that equation is V final is equal to V initial plus AT. This is nothing new here. So V final at the very highest position here is 0. V naught was 10 meters per second. Plus the acceleration is minus 10. Times t. All right, let's rewrite this. So 0, and I'm going to leave the units off here, is equal to 10. Well, plus and minus is minus. Algebra. And strictly speaking, I should not be leaving these dimensions off here, but they can look and get you a little confused. So for now, we'll leave those aside here because you're used to seeing algebra equations like this. I'm going to solve for t. So how do I do that? Let's add 10t to both sides. So on the left we have 0 plus 10t is 10t. And when I add 10t over here to this side, that's the whole reason we added 10t, was to get rid of this term on the right side of the equal sign. So we end up with 10t is equal to 10. What next to get t by itself? Oh, divide both sides by 10. So 10 over 10 is, it's 1. So t is equal to, and 10 over 10 is 1. And the dimensions here are going to be seconds. So yeah, it's going to take 1 second to stop moving up in the air. If I toss something up in the air with a speed of 20 meters per second, it'll take 2 seconds to stop moving up in the air or to reach its highest position. If I toss something up in the air with a speed of 30 meters per second, if it loses 10 meters per second every second it's moving up, it's going to take 3 seconds to stop moving up. And then all the way down, what goes up must come down. Well, not always, but frequently. These problems, they're symmetric with respect to time. That means if it takes 1 second to go to the highest position, it's going to take 1 second to come back down to the ground. If it takes 2 seconds to go to the highest position, it'll take 2 seconds to come back down. If it takes 3 seconds to reach its highest position, it'll take 3 seconds to come back down. So to get the total time in the air, you take the time it takes to get to the highest point, and you double it, so times 2. So getting back to this problem here, so it's 1 second to go up, 1 second to go up, 1 second to come back down. So the total time in the air is 2 seconds. Next, it's moving sideways. The whole time it's going up and down, it's moving sideways at 5 meters per second. And that sideways speed is constant. There's no acceleration in the horizontal direction. So then to get this delta x, Yeah, there's an equation for that. Although, I mean, look, it's moving sideways at 5 meters every second. And it does that for 2 seconds. It's going to end up 10 meters away. But for those of you that really like these equations here, so delta x is v times t. It's vx times t. I need to be careful here. Which is just, this is just a math way of saying what I just told you. If it's moving 5 meters per second for 2 seconds, it's going to move 10 meters. So this is going to be 5 meters per second times 2 seconds. So in number land, 5 times 2 is 10. And then in dimension land, this seconds cancels this one here. So the units are meters. And there you go. So we found the total time in the air, and then we use that time to find the total horizontal distance it ends up until it lands again. And there you go. All these problems, you're going to work exactly the same way here. But just remember, the physics hamster says you'll never understand this unless you do the problems.